Hi. So in this video, I'm going to talk about the basics of vectors. Okay, let's begin. So let's begin with the definition of vectors. So vectors basically are an ordered list of numbers. Okay, so this ordered is a keyword here, which means like if we have an array of numbers, let's say 1 and 2, it is not same as 2, 1. Okay, so these two are different vectors. All right. Similarly, if I extend it to 3 dimensions, then this is a vector and it is different from, let's say, 2, 1, 3. So elements in these vectors are same, but the first element of this vector is 1 and the first element of this second vector is 2. Okay, so these two are different vectors. All right. So moving on to the symbols. So for vectors, mostly we use a bold letter, lowercase, bold lowercase letter, like maybe V, or if you want to call it, let's say W. Okay, so this is the most used symbol for vectors. Okay, and we can also use this or this. Okay, or an italic V. All right. So these are the most commonly used symbols for the vectors, and I'll be using this one. Okay, so if I write this vector like this is actually a column vector. Okay, and if I write it as this in this form, then it is a row vector. All right, this is a column vector and this is a row vector. Okay, so another example of row vector would be, let's say, 1 pi minus 2. Okay, another example of column vector would be 0, maybe e or pi. Okay, so this is a column vector. It has exactly one column. And this one has exactly one row. Okay, so let's see these vectors in pictures. Okay, so Abhi, I have written this in the matrix form. Now I can also show these in graphs. Okay, so if I want to represent a vector like 1, 2, okay, so this 1 represents the this is for the x-axis and this 2 is for the y-axis. Okay, so the vector will look like this is 1 comma 2. So 1 corresponds to the x-axis and 2 corresponds to the y-axis. So this is one of the vectors. Okay, so this is the vector that represents this matrix form. Okay, and a matrix is actually defined by, it is basically described by two things. One is length and another is direction. Okay, so if I take an exact copy, see this, I have taken an exact copy of this vector, and if I place it here, notice that the length is same as the previous one, and the direction, it is also pointing in the same direction as this. So they both are actually same vectors, but their positions are different. Okay, but actually they are same vectors. All right. Similarly, this is also the same vector. This is also the same vector. Okay, if I take a vector, same vector here, this is also the same vector. Okay, so basically this is the one which is starting from the origin. Okay, Let me change the color of this. So this one actually is in the standard form. Okay, this is the standard position. This is the standard position. Other vectors are also same, okay, but this one starts from the origin. All right. So because they are same because the length and direction of each one of them is same. Okay. And apart from that, we can there can be functions. Okay, vectors can also contain functions. Vectors can also contain functions. Okay, so if I write sin x, x cos x, okay, and x, this is a vector which contains functions. Okay, so the point is that we don't need to necessarily have numbers in this matrix. Okay, we can have functions too. All right. So in this vector, this starting point of the vector is actually called uh, tail. Okay, and this end point is actually called uh, head. All right, this is the head of the vector. All right, now I'm going to talk about the addition of the vectors. Okay, addition and subtraction of the vectors. So just keep in your mind that all these are same vectors. I can just pick up any vector and take it to somewhere else, and that still remains the same vector. Okay, because the vector is described by the length and direction. Okay, so let's talk about addition of two vectors. Okay, so suppose the first vector is 1 comma 2, and the second vector is, let's say, 3. The elements of these vectors are 3 and 4. Okay, so I can represent them in the graph too, but before that, let me just add them. So vector 1 plus vector 2 will be, we just add the corresponding elements. Okay, so we have 1 plus 3 and 2 plus 4. So which will give me 4 and 6 as the resulting vector. This is your resulting vector. Let me call it V3. Okay, this is vector 3. It is the sum of the two vectors. Okay, and this is the resulting vector 3. All right. So let's quickly see this in the graphs. Okay, so 1, 2. Let me take these 1, 2, 3, 4, 5, and 6. Okay, and similarly 1, 2, 3, 4, 5. Okay, so let me take the two vectors here. So 1 comma 1 2 will, that means x is 1 and y is 2. Okay, so this. Okay, and the second vector will be 3 comma 4. So 3, 4. So I need to add these two vectors. Okay, so how do you add two vectors? So let me show you that. So suppose you have two vectors like this and you want to add them. So what you do is you can pick any one of them and take it to the head of the other vector. Okay, so you join head, you head to the tail. Okay, so for example, I can take this red vector and place it here. Okay, so let me do that. So I am picking that up. Notice that the length and direction remains the same, and like this. So your resulting vector will be from the origin till here. Okay, so let's see that. So this bold red colored vector is your resultant vector. Okay, this is the sum of two vectors. Okay, so for addition, what you do is you pick up one of the vectors, place it over the head of the other vector. Okay, so we can do that with the other vector too. So notice that we have reached till this point. Okay, this is the result. The resultant vector is from origin till this point. Okay, so let's see the same thing. If I pick up this one and place it here. Okay, so if I do that, say this, we are actually reaching at the same point. Okay, so you can pick any one of them and place it on the head of the other vector. Okay, so this is the resulting vector. Let's get to our own example. So I can pick this up. Okay, I can pick this up and place it over here. Okay, so the resultant vector is actually this. Okay, the resultant vector is in dark or orange color. Okay, this is in orange color. So this is the resulting vector. Notice that roughly it is in pictures, it is roughly 4, 6. Okay, so this is how you add two vectors. All right. Now, what about the subtraction of two vectors? So suppose that V4 is actually vector 1 minus vector 2. All right. So vector subtraction is nothing but addition of V1 vector and minus of V2 vector. Okay. So we need to know what is what if I multiply a vector with -1. Okay. Then what does what happens to it? Okay. So we need to check that. So in our case, vector V2 is 3, 4. Okay, so it is this. The first element of the vector is 3, and the second component is 4. Okay, if I multiply this by -1, okay, so what we do is we just simply multiply it with each of the components. Okay, so -1 into V2 vector is actually -1 into 3 and -1 into 4. So the resulting vector is -3 -4. Okay, so let's quickly see that in the graphs. So I have the vector v2 here. It's 3. Let's see the components. So 3 on the x-axis and 4 on the y-axis. Okay, so what if I take another vector, okay, which is the resulting vector, -3 -4. Okay, so notice that the length remains the same. Okay, so here I have points 3 comma 4 and here I have -3 comma -4. Okay, so basically the length would remain the same, but the only difference is the direction. So if I take the negative of a vector, the resulting vector is actually it is actually it is of same length but in the opposite direction. Okay, that's the difference. So that's what happens when I take the negative of a vector. Okay, so now if I want to add uh, two vectors, so basically I am adding the first vector and the second vector, but the direction has changed. Okay, so let's see that. Okay, so the first vector is 1 comma 2. Okay, 1 comma 2. All right, and the second vector is now -3 -4. So it will look like, so -3 4x -4. Okay, so this is how it will look. So now the what will be the resulting vector? So I can pick any one of them, okay, and put it over the head of the another one. So if I take this one, so this is how my resulting, this is how the result would be. I can now draw another vector from origin till this point. Okay, so it will actually look like this. One second. So this is the resulting vector. Okay, this is the resulting vector. Let me show you in the animation. So I have point, the first point is 1 comma 2. Okay, so this is 1 comma 2. Okay, this is 1 comma 2, and this is my second vector. Okay, -3 and -4. So if I add them, okay, the addition, after addition it is here. Okay, so that's my resulting vector from the origin till this point. Okay, so when I will add them, I will get, so if I want to do v1 vector minus v2 vector, it is actually 1 2 minus 3 4. Okay, and I will get 1 minus 3 2 minus 4, which is nothing but -2 -2. Okay, that's the resulting vector. Okay, so that is what is being shown here. Okay, this is actually -2 comma -2. Okay, yeah, -2 comma -2. All right, so that's how we do addition or subtraction of two vectors. Okay, and similarly, if I want to do a scalar multiplication, the scalars are basically the constants. So let's say we have vector v1. I want to multiply it with a constant, and let's call the resulting vector v2. Okay, so suppose v1 vector is again 1 comma 2. Okay, and c is, let's say, -3. Then c v1 vector is actually -3 into 1 2, which is equal to -3 and -6. Okay, so when you multiply a vector by a constant, okay, it is actually being either stretched or de-stretched. Okay, so suppose I multiply a vector with a constant which is positive and more than one. Okay, then the vector becomes longer in length. Okay, if I multiply it with a constant which is more than one, uh, then it actually becomes longer. Okay, in the same direction, it becomes 2 comma 4. Let me show you that. So the vector here initially is 1 comma 2. I'm multiplying that by 2 and I'm getting 2 comma 4. Okay, so so after multiplying, I'm getting 2 comma 4. Okay, so the initial vector is still here. Okay, and after multiplying by 2, in the same direction, this vector is being stretched. Okay. What if I multiply it by 0.5? A positive number, but less than 1. Okay. So if I multiply it by 0.5, 1 into 0.5 is 0.5, and 2 into 0.5 is 1. So see that now this vector is de-stretched. Okay. Initially its length was till this point, and now it is only till here. Okay. The same direction, but a shorter length. Okay. Similarly, if I multiply it by, let's say, -1, then I'll get -1 here and -2 here. Okay. So notice that the it is stretched, but in the it is the same vector, but in the opposite direction. What if I do it? What if I multiply it by -2? Then I will get -2 here and -4 here, and again see that uh, this vector is now of opposite direction because I multiplied by with a negative number, and since I multiplied it with a number which is greater than, which is even smaller than -1. Okay, so it is stretched but in the opposite direction. Okay, so if the mode of the of that scalar is greater than 1, okay, then in that case the vector becomes longer. Okay, and if I multiply it by negative number, it becomes it goes to the opposite direction. Okay, so that's how it works. So these are the basics of vectors. We have talked about definition of vectors, addition of vectors, subtraction of vectors, and vector scalar multiplication. Thank you.